Hi, and welcome to my video on the proxy design pattern. So, the proxy pattern is a structural pattern where a class represents the functionality of another class. That might make sense if you've heard the word proxy before. It typically means that there's a layer between you and whatever you're interacting with. So a real world example would be like your check and credit card is a proxy for the money in your bank account. It can be used in place of your money, and it provides a way to access that money. So the proxy design itself is typically implemented through an interface. So you have an interface and it's got some methods in it, and then your proxy and your actual object both implement that interface. So if we've got a cache interface, maybe it's got a spend cache method, then both your proxy and your actual cache object would have that method. But your proxy represents your cache object. So it would typically have an instance of the actual object it's trying to represent in there. But the proxy and the actual object can have any number of fields or methods. So on the right diagram, you'd see that the client can interact with the proxy. The proxy will then send their request to the actual object, and the actual object will respond to the proxy, and then the proxy will respond to the client. And you might ask, well, why do we even need that middle layer? It just makes things more confusing. So some examples that you can find are for protection. A protection proxy can be used to control access rights to an object. So maybe your object's an ATM machine, and you don't want to give someone full access to your ATM machine. Maybe you just want to give them a few access to a few methods. So your proxy will have methods that allow them to like withdraw $20 or enter their PIN number. But the ATM machine might have more objects that they can't see, like withdraw all the money from the ATM. So it's just a way to limit access to fields and methods of the actual object class. Another example is a remote proxy. So this is a way to control access to a remote object. So if you've got a proxy that's a local representation of some object on a different address space, then you can give commands to your proxy and then it'll communicate over the network to the remote object. The third reason would be a virtual proxy, and this is typically for when an object's not yet been created. The example you'll find with virtual proxies are typically for resource-intensive objects like an image file, where you've got a very high definition image and it takes up a lot of memory and space. Then you could have a proxy that just stores a reference to that image. So it can call image commands like get width and get height that don't actually load the image. But then it can also call commands like display, and that would actually load the image. So the proxy gives you a way to basically load the image on demand so that you can save your computer resources. Another example of virtual proxy is like time delay commands or acting as a state machine. And that's the one I wanted to dive a little more in depth on. So I prepared a video here. This is from a video game called League of Legends. There's two characters on the screen. There's a blue bird, and then there's a guy wearing some green armor. Now the bird has the property that when it dies, it becomes an egg, and then after a short time, it's reborn because it's a phoenix. And in this game, you can click on the ground, and a green arrow will indicate that you've clicked there, and your character will try to move there. So let's watch the video. You can see me click on the ground and the green arrow, my character moving around. Now the guy will come over and start killing me and turn me into an egg. So keep an eye on the gold cursor above the two characters. Once the bird turns into an egg, I'll click on the ground some more and you can see that the green arrow indicates that I'm trying to move there, but the egg doesn't move, it's just stuck. I've stopped clicking, but the bird comes back to life and immediately moves to where I last clicked. So that kind of indicates that maybe there's some proxy design going on in the background because that movement command had to be queued up somewhere. So here's a Java method that might shed some light on this. So imagine that we have a bird class, which is our actual object, and then we have a proxy bird class. And they both implement an interface, some movement interface that has a method called move. So this movement implementation would be for the proxy bird class. And what it would do is it'd take an X position and a Y position. It would check if we're in bird form, and if we are, then it would say for the actual bird object to move. And if we're not, then it would just set a rally point for later. And so that's a way that our proxy could be acting as a state machine. and it only tells our bird object, actual bird object, to move if we're in the bird state. So thanks for watching, and I hope you learned a lot about proxy design.